So this is one case we did for showing it was for a special machine or oven or whatever it is, where we want to put those bottles on this special conveyor. And there we take from you, Christer, again, with like how to conceptually think about modeling something like this. So it's based on the standard, but extended or modified, I could say. Not much, but slightly. And then in the end, it gives a really nice presentation where the customer can see their machine exactly how it would look like. So they understand immediately how this would work. And the modeling was done to check, can we handle the capacity of this system with those robots? So
I think the gripper is really nice with that red detail there on the gripper, for example, makes it stand out. And the motors on top of the, is it a cleaner or oven? It's heating.
Yeah, it's heating. It's heating. So this is a good example. Also, as you said, with the gripper, we have mainly, I would say, 2 persons working with visual components, and maybe it was luck or maybe it was a strategy or both. We have one person coming from robotic programming, a robot offline programmer with a lot of knowledge about that. And then we have another person which comes from the CAD design side. So therefore we can have super cool grippers, nice layouts, but we also have a really nice understanding of the robot's behavior and what we should do there. So,
but then you also have you who have understanding of code.
Yeah.
Or a willingness to understand.
I'm interested in that, yes. I know something. I usually say I know a little bit about a lot of stuff. So I think we are a good team here, and that made it possible. And also an interest in moving forward, developing how we work and going further, supporting our business.
I think one detail in this layout, which maybe is overseen, is on the right-hand side on the conveyor, the input, you can see that the spacing between the bottles are exactly the same. But on the output, the spacing actually varies quite a lot, depending on the cycle time of the robot reaching the furthest away bottles or the closest ones.
Exactly.
And this is something which maybe you don't really think about or foresee. If we look now, there is this big gap over here, for example, and then we have small building the gaps longer. And that could impact the process downstream, that you need to have some bladder stopper stopping it and so on.
Exactly. And it's exactly those things you don't want to realize after building the system. We did not do it in this case because maybe it was not necessary or relevant, but often we modify the input stream as well, like having a random or small deviations in the input to stress test the system. How much can we accept or handle? So that's super important. And we're going more and more now into Monte Carlo simulations and in that direction, really trying, because that's where we will end up in a couple of years or 1 year, maybe. Understanding a even more realistic process, not only ideal conditions or worst case scenarios.
There we have this new component actually in ECAD also, which maybe you guys haven't seen yet, that is called Scenario Runner. And that will basically allow you to run many tests. So as long as you have a variable with a number, or actually the variable could be strings also, but then it should be defined. Don't need to be defined either. Okay, you have any variable that does something, then you can add that to a test run. But we did one test that took too much time. For example, if you want to have 3 different inputs and you want to test them, system will kind of match those together. So when I had 3 different variables with quite many combinations, it wanted to run over 1,000 runs to go through those. So I guess testing with 2 variables, or if you want to have more variables, you should limit the amount of different values those variables can have.
Yeah. That's where we will move, understanding how and to create value from those kind of scenario simulations, because it could explode